Got a few things that I wanted to discuss here really quickly, and just for the record, it is going to be very fast because I only have a couple minutes. Um, First and foremost, I got a question in email that was a fantastic question that was something that actually deserved to go to the discussion boards, which is the other part of this. And what we've got here is kind of the starting point. If we look at that step of a mechanism, okay, so the first and foremost thing that we see is that what we're looking at here would be H3O plus. And I see lots of people trying to do things with the organic compound that's drawn first. And that makes sense. It's drawn first. So you think, oh, that's the thing I got to do first. No. The thing you've got to do first is identify which of your starting materials is the most reactive. The most reactive here is H3O plus. Your whole goal at this point, fix H3O plus. Right? So you have to address why it is reactive. The why it is reactive is that we have an extra, or we have a positive charge on that oxygen. So I need electrons from somewhere. The easiest place to get that, because oxygen already has its octet, is to take it from that bond. Okay? That means H plus is floating around. That's bad. So I need something to pick that up. That now needs to be our starting organic compound in this particular case. Okay? So that starting organic compound now has to supply electrons. So now the question comes, where does it supply the electrons from? So you have to look at that structure and decide, where are they? And so there's really two places here. You have the lone pair on the oxygen, and you also have that pi bond. Right? Both of those are sources of electrons. Which one should you use in your overall mechanism? So this is where things become a bit dodgy on deciding how to move through a mechanism. Right? If you don't know, which is perfectly acceptable, try both. Right? So in one case, what we're saying is the lone pair comes in, reacts with the hydrogen. The result of that arrow pushing would then be I have an oxygen with a positive charge, and that would have my H2O, right? Well, what if the pi bond picked up those electrons instead? Okay, well, now the result would still be the oxygen with the hydrogen on it, okay? And that one can be tricky for some students, so I'll go through and walk through the why of that in a second. But then we would have a positive charge down on that carbon. We would still be producing H2O. For those students that are wondering, well, why did you put it on the oxygen and not on the carbon? Well, what happens if you put it on the carbon? Okay, and the two lone pairs. If we look at that result, you might be like, well, I don't see what's wrong. Well, the what's wrong is that that oxygen does not have an octet. So if we're now going to compare the purple and the red one, which one of those is the more likely one? Where the carbon is missing an octet or the oxygen? Oxygen being the most electronegative element that we really work with, because we don't really work with fluorine all that much, okay? It wants its octet, which means this purple structure is god-awful and it makes no sense. This is why when we show that pi bond react, right, it's implied where that hydrogen is going to go. It's going to immediately go with the oxygen and the carbon's going to be missing, right? So we know that, right? That is something that you should have seen when we did addition reactions, both in first semester and second semester, because that same pattern shows up, right? The next part, we had these two pathways. We'll call them the red and the blue pathway. Which one is correct? Okay, that becomes a bit dodgy to answer, at least in my opinion. So to identify which one is correct, we need to see what the difference is. So if we go through, we're producing water in both cases, so that's not a big deal. If we take a look at the top one, we're putting a positive charge on oxygen. At the bottom one, we're putting a positive charge on the carbon. So we might again say, well, oxygen doesn't want to be positive, so shouldn't the bottom one be the more correct one? Okay? I like that logic. That logic makes a lot of sense, because what you're looking at is the displacement of electrons in the molecule to the direction that makes the most sense. However, the big issue there goes all the way back to first semester, the very beginning unit, when we talk about Lewis structures. okay? And in particular, resonance. What is the relationship between these two structures? All I have to do is move that pi bond up to the oxygen. These two structures represent the exact same compound. They're resonance structures. Shouldn't that push even further to saying it doesn't matter which place we use for our electrons? For your understanding, no, it makes no difference. Do whatever feels comfortable for you. However, if you're going to move into a mechanism that is graded, we now have to be a little bit more careful because there are rules that we have to follow. The number one rule of drawing Lewis structures correctly is satisfy octets. That's like the don't break this. You have to have a full octet to have a good Lewis structure. We look at the red structure, that carbon is missing its octet. That is bad. And for those people saying, well, the oxygen is still positive, so it's missing its octet. This can come from how you count electrons. There are 2, 4, 6, 8 electrons around the oxygen. It has its octet. Just because it's positive doesn't mean it's missing an octet. It just means how it's sharing the electrons is not in a favorable state. Okay? What does this all mean? That means any mechanism, arrows that you show back here, that result in the formation of a bad Lewis structure, i.e. this red one, are invalid. Which means when you go through to supplying the electrons, the ones that you need to be using are the lone pair in this case, not the pi bond. Okay? Does it make a big deal? No, not really. Okay? But if you're being asked on a test, you need to be specific with what you're working with. If you're being asked in a software like our SmartWork that asks for precision, that's an important thing to know. Okay. The next thing I want to kind of point out is that in this particular reaction that's shown here, okay, we set it up so that you could follow through the mechanism more accurately. Okay. Really, what we started with was an alcohol and the carbonyl and this acid source. So all of those things are present. So once we identify this as H+, we need to find electrons. Well, where are those electrons? They're in the lone pair. They're in the pi bond. They're in this lone pair. Which of those should react with the H+? Okay, and this becomes one of the kind of dodgy things in second semester that becomes a bit challenging. In first semester, if we look at organic chemistry as a maze, in first semester, our maze was relatively simple. Okay, you start here and you end here. This was first semester. Okay? Maybe towards the end, we did something like this. Okay? But by and far, what you could see was that I just needed to move straight through the maze. Second semester becomes a little bit more challenging. We still have a start and an end, but when we look at that maze, we're going to get lots of branch points. Okay? You have to make a decision at each of those branch points at where to go. Okay? What I see a lot of students doing is saying, oh, start to end, I'm just going to go straight through. And then we hit here and hit a dead end, and they go, well, I can't do anything anymore. You absolutely can. You hit a branch point. Acknowledging that this first step was a branch point becomes important. You hit a dead end when you said it reacted with the alcohol. So you now have to go back to your branch point and say, well, where should I try now? Well, now let's try the pi bond. Okay, well, that pi bond, as far as branching goes, is a little bit weird. But if we go through and do the pi bond, you end at a structure that is missing an octet. And as far as a mechanism goes, that's another dead end. Go back to your branch point, okay, and see what happens. Okay? So then you'd be like, okay, well, it's only 3 things, so it's not a big deal. But that then encounters another branch point. And it encounters another branch point. And what OChem 2 is about is how do you navigate each of those branch points and recognize when you're moving forward versus when you're running into a dead end. Well, think about how you walk through a maze, right? If you're going to go through a maze, you're going to track through it. And for those of you that are really adventurous with pens, start drawing with a pen and go, oh, dang, I hit a dead end. And you go back to that branch point. What I'm seeing a lot of people doing is just ignoring the fact that they made a decision, right? You need to think about every single arrow you show, right? When should you think about it? Now. When should you not be thinking about it? When you get to the exam. Because what will happen is if you think about those branch points at every single step while you're working on the homework, you will end up recognizing when a dead end is about to appear. You will be able to stand at that first branch point and be like, that mofo is trying to make me think that I can go straight ahead and get right to the end in one fell swoop. I'm not going to trust him. I'm going to try a different path. Sweet. Okay? You're now starting to think like a chemist and think through that process and try and plan out the steps ahead. Think back to solving a maze. Even those of you using pen, you're probably not just moving straight through. You're looking ahead to the next branch point. Same thing with chess. Okay? OChem is about thinking a couple steps ahead on what things are going to show up. You have to hold those structures in your head, or you write them down. This is what I've been saying since day one. You need to write them down. This is why we have paper homework. This is why we have the discussion board where you're supposed to post your work. Because when you post your work, other people can look at it and help you see that you made a mistake. Okay? That's the point of writing things down, is finding those errors. If you don't write them down, you will never see your errors until you get to the exam and you're like, I have no idea how to solve. That's because you never found how to do it wrong. Okay? You only saw how to do it right. The textbook is only going to show you how to do it right. Sometimes when I walk through the mechanisms in class or in the videos, you'll see me go into a dead end. People complain about it all the time. Tough. You need to be able to see a dead end. You have to know that that did not work. Right? And that is challenging. Okay? Because we're not in person, it's even more imperative that you push to find those dead ends. So start drawing it out and be like, well, I don't know if this is a dead end. Good thing to post to Piazza. Post it up there and be like, did I run into a dead end? Because I can't tell. Right? You haven't learned it yet, so you need that practice. And you need an expert to be able to look at your work and say, that is a dead end, turn around. Right? That's what I'm here for. That's what your classmates are here for, to help you turn around and recognize that you made a mistake. Okay? With that repeated processing, you can make it through the maze. If you aren't doing that processing, you're getting lucky that you're choosing the correct path. Luck only takes you so far, and in OChem, luck usually boils down to less than 10% odds. A 10% in the class is very much failing. Okay? So please try and struggle through, find those dead ends, post them on Piazza, okay? Which gets us to the next part of this. Okay? I got a comment, which was a fantastic comment, though I'm not super happy with how I got it. I got it in a private message, okay, which is okay, saying here are some ideas for discussion board or engagement in the class. So telling students to post something new that they learned, something you found helpful, something you need more clarification on, anything you can do in the instruction methods to help out. That is, I'm literally asked you to do that. Okay? And I'm not saying that as like a, why didn't you see what I said? Because I didn't use those words, but that's what I've asked you to do. Post to the discussion board your questions, your thoughts, your concerns. Okay? That is so open-ended that I think the intent behind this kind of suggestion is that we need to close that open-endedness. Right? Life is open-ended. Okay? You're going to have to struggle through things and kind of pick these things out and be able to ask for help. Nearly all of you are going to post bachelor type programs, right? In those past post-bachelor programs, the biggest thing that you need to learn as a student is to ask for help. And if you don't ask for help, you end up struggling or failing out, right? And I don't want that. So this is where we have to kind of push out there. I'm providing you that forum with Piazza to do it, okay? Use Piazza, please, okay? That is the sole purpose behind that, okay? So if you find it more helpful, okay, this is kind of a leading video for this. I'll post a follow-up. Do you think this is a good idea? Do we need these weekly posts of you're supposed to put something here? Absolutely. Hands down, I'll do it. Okay. But I'm going to say I need to see that come back from you, which means you have to respond to this video. Okay? I think that's a fair trade-off. And if we're seeing that, then cool. I'll go ahead and put a little bit more of a lead into Piazza saying, hey, you need to post something about this topic. Okay. That topic really being, what are your questions, comments, or concerns about the class moving forwards? Okay. All of those things I'm asking you to do. Okay. With that, I talked too long already. Standard, typical. I absolutely appreciate the questions I'm getting in email. I'm absolutely appreciating the comments in Piazza, both public and private. Okay. Those are useful because you're starting to move towards that engagement. It is exceptionally challenging to put yourself out there so that everybody can see it. But that's really what you need to do. You have to put it out there so that everybody can see it. And that's a challenge. Okay, that absolutely is. I completely agree with that. But we got to do it. Okay, we really have to. Okay. One big suggestion to help with that, you can post anonymously. Okay, there should be a button in your post thing. You can say post anonymous. That will post anonymous to the class. It does not post anonymous to me. So I can still give you credit for having engaged, but then nobody has to know it was you. Okay. That was a lot. Hopefully that's okay. And hopefully nobody feels bad that you got called out, because that's actually multiple people that got called out-ish, okay, within this. Please keep the comments coming. I want you to be part of the class. So let's keep with that. Okay. Thank you.